Welcome to our latest video, which is an introduction to rate equations. This video is suitable for A-level students. By the end of this video lesson, you should be able to understand the concept of a rate equation and that it shows chemists the mathematical relationship that exists between the concentration of reactants and the reaction rate. You should also be able to explain the meaning of the term reaction order and understand how to work out the units of the rate constant K. Now, in our previous video lesson, we recapped the concepts covered at AS level, including collision theory, which tells us that there are two ways of increasing the rate of a reaction. Firstly, by increasing the frequency of collisions, and secondly, by increasing the percentage of particles with energies equal or greater than the activation energy. Now, collision theory tells us that when particles collide with the right amount of energy, the activation energy, reactions occur. Now, in practice, the frequency of collisions is increased by increasing the concentration of reactants in solution, or increasing the pressure of gaseous reactants, or even by increasing the surface area of solid reactants. Now, increases in temperature or the presence of a catalyst increases the rate not by increasing the frequency of collisions, but by increasing the percentage of particles which possess the activation energy or greater. Now, at A2 level, we'll be focusing in detail on how changing the concentration of each reactant affects the rate of a reaction. And the approach is quantitative, which means we'll study by how much altering the concentration of a reactant will affect the rate. Now, for many reactions involving liquids or gases, increasing the concentration of reactants will increase the rate of a reaction. However, in a few reactions, increasing the concentration of one of the reactants may have little effect. Now, changing the concentration of substances taking part in a reaction usually changes the rate of a reaction, and a rate equation shows this effect mathematically. Orders of reaction are part of the rate equation. So in the next part of this video, we're going to look at the composition of the rate equation and what the rate equation tells us. So if we consider a chemical reaction A plus B goes to products, although the rate is dependent on the concentrations of A and B, we cannot simply say that the rate is proportional to the concentrations of both A and B, because the relationship is more complicated than that. So reaction rate is proportional to the concentration of A raised to a power m and the concentration of B raised to a power n. So we can express this as reaction rate is equal to K times the concentration of A raised to a power m times the concentration of B raised to a power n. Now, square brackets here represent concentration of these reactants, and m and n are the orders. Now, order is the power that concentration is raised to in the rate equation. And these indices m and n are usually integers, often 0, 1 or 2, and they're characteristics of the reaction. You can only determine the order, the power that concentration is raised to in the rate equation, by carrying out experiments. You can't determine these values by looking at a chemical equation. They can only be determined experimentally. So the order of a reaction tells us the exact dependence of rate on concentration, and this slide shows the rate equation. So if we have a reaction A plus B going to products, rate is equal to K times the concentration of A raised to a power, let's call it m, times the concentration of B raised to a power n. Now, m and n are the orders. The reaction order is m with respect to A. It's the power that the concentration is raised to in the rate equation. And the reaction order is n with respect to reactant B, because the concentration of B is raised to a power n. Now the overall order of the reaction is m plus n. Now the values that m and n take, the orders with respect to each concentration term, can only be determined experimentally. And the proportionality constant k is called the rate constant, and the rate constant k is different for every reaction and it varies with temperature. So it must be quoted at a temperature. You have to quote the value of k at a temperature for it to be meaningful, because it varies with temperature. Now order is simply the power that the concentration of reactant is raised to in the rate equation. So now let's test your understanding of what we've learned so far with some practice questions. Here's the first practice question. Read for the question, pause the video, have a go at it, and then we'll go for the answer. So question 1 is asking you to write a rate equation for this reaction. So it's x plus y goes to products, and the reaction has been determined to be first order with respect to reactant x and second order with respect to y. So rate is equal to k times the concentration of x times the concentration of y squared. And this is because it's second order with respect to y and it's first order with respect to x. So x is effectively raised to the power 1 and y raised to the power 2. So overall, this reaction is third order because x is order 1, y is order 2, 1 plus 2 equals 3. So overall, the order is third order. So it's also worth mentioning here that in a rate equation, the rate constant is denoted by a small k, not a capital K. So here's our second practice question. Read for the question, pause the video, have a go at it, and then we'll go for the answers. So in question 2, the rate equation is given to you. Rate is equal to k times the concentration of the bromate ion times the concentration of the bromide ion times the concentration of the hydrogen ion raised to the power 2. So the order with respect to the bromate ion is first order because it's raised to the power 1. The order with respect to the bromide ion is also first order because it's raised to the power 1. And the order with respect to the hydrogen ions, H+, is second order because it's raised to the power 2 in this rate equation. So here's our next practice question. It's asking you to write down a rate expression that is first order with respect to the concentration of A and second order with respect to both the concentrations of B and C, and it's asking you to work out the overall order of the reaction. Pause the video, have a go at it, and then we'll go for the answers. So this question is asking us to write a rate equation for the following reaction where it's first order with respect to the concentration of A and second order with respect to both B and C. So we use this information to write the rate equation. So rate is equal to K, the rate constant, times the concentration of A times the concentration of B raised to the power 2 times the concentration of C raised to the power 2. So overall, this reaction is fifth order because A is first order, B is second order, and C is second order. So therefore, overall, it's fifth order. Now, the rate equation tells us something different to the chemical equation. The chemical equation summarizes what you start with, the reactants, and what you end up with, the products. And reactions can often take place in a number of steps. Now, the rate equation is based on the slowest step in a reaction. We call this the rate determining step. And the rate equation tells us the species that affect the rate. So by species we mean atoms, molecules or ions. And species that appear in the chemical equation do not necessarily appear in the rate equation. However, catalysts which do not appear in the chemical equation may appear in the rate equation. Now if we take the reaction of propanone and iodine, H plus ions act as a catalyst here, and the rate equation has been found experimentally to be as follows. Rate is equal to K times the concentration of propanone times the concentration of H plus ions. The reaction is first order with respect to both the concentration of propanone and the concentration of H plus ions. Now the concentration of iodine does not appear in the rate equation, and that's because changing the concentration of iodine here does not affect the rate of reaction. Now we say that this reaction is zero order with respect to iodine because changing the concentration of iodine does not affect the rate of reaction. Now this might be surprising to you. However, the rate equation is based on the rate determining step, the slowest step in the reaction, and iodine is not part of that step. So therefore we say it's zero order with respect to iodine because changing the concentration of iodine will not affect the rate of reaction. Now it's worth remembering that if you see a species, a molecule, an atom or an ion present in a rate equation but not the chemical equation, that species is a catalyst because it speeds up the rate of a chemical reaction, but we don't list catalysts in the overall equation because a catalyst is not used up in the reaction. Now in the first section of this video we looked at the concept of a rate equation. In the final section of the video we're going to look at how we work out the units for the rate constant K. Now the units of rate constants vary depending on the overall order of the reaction. Now for a first order reaction we can write the following rate equation. Rate would be equal to K times the concentration of our reactant, let's call it A. So rate is equal to K times the concentration A. Now the rate of a chemical reaction is normally expressed as the change in concentration of reactants and products with respect to time. So the units of rate are normally moles per decimeter cubed per second. So moles per decimeter cubed, seconds to the minus 1. And the units of concentration for A would just be moles per decimeter cubed. Now if we substitute these units into the rate equation, you can find the units of K. So rate is measured in moles per decimeter cubed, seconds to the minus 1, and that would be equal to K times the concentration of A, which is measured in moles per decimeter cubed. So if we rearrange this, K is equal to moles per decimeter cubed, seconds to the minus 1, divided by moles per decimeter cubed. Now because I've got moles per decimeter cubed on the top and bottom here, they cancel out. So K is equal to seconds to the minus 1, and that would be the units of K for a first order reaction. So now let's test your understanding of this with some practice questions. Here's the first practice question. Read through the question, pause the video, have a go at it, and then we'll go for the answer. So question 1 here is asking you to work out the units for the rate constant K for an overall second order reaction. Assume the following rate equation or rate expression. Rate equals K times the concentration of A times the concentration of B. So once again, to work out the units, we just substitute in the units for rate and the units for concentration. So rate is measured in moles per decimeter cubed, seconds to the minus 1. Concentration is moles per decimeter cubed. So moles per decimeter cubed, seconds to minus 1 is equal to K times moles per decimeter cubed times moles per decimeter cubed. So to work out the units of K, I just rearrange this equation. So it would be moles per decimeter cubed, seconds to the minus 1, over moles per decimeter cubed times moles per decimeter cubed. So that's equal to K. So to work out the units of K, I cancel out where I can. So moles per decimeter cubed is on the top and bottom here, so these will cancel out. So I'll be left with seconds to the minus 1 over moles per decimeter cubed, and that will be equal to K. Now it's important we write this all on the same line. So to do this, it simply becomes moles to the minus 1 dm to the 3 seconds to the minus 1. And that will be the units for second order reactions. Now I always recommend to students that they don't try to learn the units for rate constants, that they just work them out using the method I'm showing you here. So here's our second practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So for question 2, we have the reaction between oxygen and nitrogen monoxide, and the first part of this question is asking you to write an expression for the rate of the reaction, in other words, the rate equation. Now, the question tells you that it's first order with respect to oxygen and second order with respect to nitrogen monoxide. So therefore, because of this, we write the following equation. So we have to remember it's first order with respect to oxygen, second order with respect to nitrogen monoxide. So therefore, rate is equal to K times the concentration of nitrogen monoxide raised to the power 2 times the concentration of O2. And this is a third order overall reaction. So question 2b is asking us to work out the units of K, and we have the rate equation. Rate is equal to K times the concentration of NO squared times the concentration of O2. So all we do is substitute in the units for rate and the units of concentration, moles per decimeter cubed. So rate is moles per decimeter cubed, seconds to the minus 1, and this will be equal to K times moles per decimeter cubed times moles per decimeter cubed times moles per decimeter cubed, because we've got 3 concentration terms on the right. So if we rearrange this, K is equal to moles per decimeter cubed, seconds to the minus 1, over moles per decimeter cubed times moles per decimeter cubed times moles per decimeter cubed. Now once again we look here to see if we can cancel out any of the concentration terms. So there's moles per decimeter cubed on the top, and there's 3 moles per decimeter cubed terms on the bottom. So if we cancel one on the top and one on the bottom, we're then left with K being equal to S to the minus 1 over moles per decimeter cubed times moles per decimeter cubed. And moles per decimeter cubed times moles per decimeter cubed is moles squared dm to the minus 6. Now we must write this on the same line. So K is equal to moles to the minus 2 dm to the 6 s to the minus 1. And that would be the units for a third order reaction. So that concludes this video lesson. So after watching this video, you should now understand the concept of a rate equation, and that it shows chemists the mathematical relationship that exists between the concentration of reactants and the reaction rate. Finally, you should be able to explain the meaning of the term reaction order and understand how to work out the units of the rate constant K. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.